Science is based on measurement. In particular, when a scientist looks at a problem, they make a hypothesis as to how they think nature is actually working. Then they make a prediction of the outcome of a particular experiment. That prediction must include measurable properties. So measurements are central to all of science. These measurements are typically characterized by two concepts, and that is precision and accuracy. Now, we need one other concept, oddly enough, to talk about these two. So let's consider, for example, we're measuring a property x. So suppose this is the x-axis, this is 0, and this, right here, okay, is the actual value of x for this particular system. Now, we will never, ever be able to know the actual value of x. Every measurement we take will be characterized by a certain amount of error. So we use statistical methods to get as close as possible to the real value. Now, a couple of concepts here. Okay, precision. Precision is literally the consistency of your measurements. In other words, your measurements should be well grouped. They should be close to each other, so you are consistently getting a similar value for your measurement. Another concept is something called trueness, and it essentially is exactly what it says. How close are you? How close is your measurement to the actual value? Accuracy, then, is high precision and good high trueness. All right, so let's look at all of this graphically. So here's an example again. Here is my axis. This is 0. This is my true value for x. This is my actual value for x. Okay, this particular measurement, suppose those are my 4 values. This particular measurement has high precision, but low trueness. Everything's clustered, but they're not close to the actual value. On the other hand, we can have this, okay, where I have, okay, the average value of these measurements will probably be pretty close to the actual value, okay, but they're not clustered close together. So this has low precision, but high trueness. Finally, oops, spelled that wrong, we have this case, where this is the actual value, and I get this. Okay? The values are very close together, and the average of those values is very close to the actual value. This is high precision and high trueness. This is high accuracy. Now, I mentioned that in science we use statistics to, if you will, process our measurements to give us a good answer. And there are two statistical quantities we use in particular, and that is the average value of x, also known as the mean, and the standard deviation. Okay, so let's talk about both of those. You probably know what an average is. You add up all the values and then you divide by the number of values. Okay. The average is essentially your prediction for the value of the measurement. And we denote the average, or we denote the mean, as x bar. Now, it's a little trickier to talk about the standard deviation. The standard deviation is a measure of the spread. And I'll just write this as standard deviation, SD. Standard deviation tells you about the spread, or better yet, the average spread of the points of the measurements. So, roughly speaking, okay, the standard deviation is the average distance, or the average difference between each measurement and the mean value. So, for example, I have a particular measurement. Okay. This, notice the I did that wrong. This would be the difference between a particular measurement and the average value. I then add all of those up and calculate literally the average of that difference. Okay? Now, this is not exactly the same formula, but it's good enough for conceptual purposes. This is the standard deviation. Now, to actually make this work, we actually take the difference between the value and the average, square it. This way it doesn't matter if it's bigger or smaller than the average. Take the average of that and then take the square root. But this will do for now. So, how do we apply these? Precision implies low standard deviation. Trueness means the mean is close to the actual value. And finally, accuracy is both of these. When we do a measurement in science, we always aim for accuracy.